Assalamualaikum warahmatullahi wabarakatuh and hello everyone. Okay, so we will continue our lecture on chapter 5, which is position, displacement and label sensor. Okay, we are going to discuss 4 types of sensor in this chapter, which is we will cover into potentiometric sensor, capacitive sensor, inductive and magnetic sensor, and lastly we will look at the optical sensor. Alright, first of all, in this part we will going to discuss about the potentiometric sensor. Okay, so potentiometric sensor is one type of the position sensor. It's is inexpensive and easy to use, and that's why it most commonly used as one of the position sensor. Alright, so there are two types of potentiometric sensor, which is they can be either in angular or linear, which is in terms of its movement, and which cause the resistance value between the wiper or slider and the two ends connection to change, giving an electrical signal output that has a proportional relationship between the actual wiper position on the resistive track and its resistance value. So in other words, we can say that resistance is proportional to position. Okay, so we look at back the equation of resistance, which is R is equal to rho L over A, which is R is the resistance value, rho is the permittivity, L is the length of the wire, and A is the area. Okay, so from this equation we know that the length of the wire is directly proportional to the resistance. If we change the value of length of the wire, it will change the value of resistance. So that's by making an object to control the length of the wire, as it is done in a port, displacement measurement can be performed. Alright, another one is potentiometric sensor is one of the active type sensor because it needs excitation signal to run it. A resistance measurement required passage of an electrical current through the port wire to for the sensor to be function. Alright, so potentiometers come in a wide range of design and size, such as the commonly available around rotational type or the longer and flat line linear slider types. Okay, so if you can see at this figure, there are two types that I previously mentioned, which is rotational and linear. This one is rotational and this one is linear. Okay, so on rotational potentiometer, the slider we call is a slider or wiper. It can be changed turns between the tracks. So in movement of the track will change the value of resistance or length. Okay, so for linear is quite easy. We can know if we change the slider, move up or downward, okay, it will give the change of length of wire. Okay, next, okay, how we want to do measurement of the displacement by using the potentiometer. Okay, it's quite easy. If you remember how to calculate the voltage divider, okay, so this one is most likely like a voltage divider circuit. Okay, so if you look at the figure, we have a DC reference voltage, which is we apply across the two outer fields connection forming the resistive element. Alright, so this one is our DC reference voltage. Okay, so the output voltage signal is taken from the wiper terminal of the sliding contact. Okay, so we measure the measure the voltage from here. For example, we have a distance D, and then we measure the voltage from here to here, which is in ratio with our reference voltage. Okay, for example, in this configuration, if you apply a 10 volt voltage across the resistive element, here we apply 10 volt, okay, of the potentiometer, the maximum outer voltage will be equal to the supply voltage at 10 volts. Okay, so means that the full scale length is equal to 10 volts. Alright. Then the potential wiper will vary the output signal from 0 to 10 volts. So the output voltage will be in between 10 to 10 volt, 0 to 10 volts. Okay, if let's say the output voltage indicating is 5 volt, means that the slider is will be going to be in halfway of the displacement, so it will be somewhere here. It will be in the center position. Alright, so how we alright then, okay, so how we want to calculate the output voltage proportional to the displacement. Okay, we can use this equation, which is V is equal to E d small d over capital D, which is E is the our reference voltage, D is our measured displacement, and D is full scale displacement. Alright, I hope all of you will be understand this equation. Alright, so this one is another example of gravitational fluid level sensor with a float. Okay, so this one they are use variable sensor in linear potentiometer, okay, to detect the fluid level sensor. Alright, so it's quite popular to be used in a toilet tank. The clandestine main element is a float, which is a device. Why? Because it's a device which is have density lower than of water. In most tank, it is directly coupled water valve to keep it either open or shut, depending on how much water the tank would be holds. So the float is a detector of the position of the water surface. For the measurement purpose, the float can be coupled to a position transducer such as potentiometric, magnetic, capacitive, or any direct sensor. Okay, so this one is like I showed you previously, which is rotary potentiometer. Okay, so they have wiper, which is they have wiper here, which is they can be moved towards along the track. So as it move from one here to here, one end to another end, the value of resistance will be changed. Okay, so I will give you another example of on the video. I will upload it in the Google Classroom. Alright, so that's all for this part. Okay, thank you. Let's